So good afternoon. So we started with the Python programming language, and we looked at some concepts which is very basic and important to the Python programming. We looked at the input output in Python. We looked at the operators and operands. Okay, so let's look at some of the control structures. In programming, basically, we have two statements or two constructs that have been designed to control the flow of your program, and is usually the if and the switch. But Python basically focus on if, though there is an implementation of switch, but it's not really something that Python is. I don't know what word to use. Maybe close that door. It's not something that Python is is heavy about or focus on. So we may not even discuss it because I don't think I've even used switch. I can't remember if I've used switch, but I use if a lot. But that switch, I doubt. So we just leave that for now. We look at the other part, which is the if construct. So it's called a construct because it involves multiple components. So you have the if, you have the else, and then in between the if and else is what you want the program to do. And they are usually used with the what is it called? The comparison and logical operators. So maybe we should start from there, okay? Before we look at the control structures itself. Let's look at the operators that are used to compare values in Python. Okay, every other language has their own, but like what is it called? Like not equal to. In some program is written like this. Okay, but in Python, that's not the case. It's written like this. So we need to know what these operators are. So let's start with the conditional operators, which we use with our control structures. So let's have some numbers. Let's say a is 10. So I'll just use that my ABC is equal to 10 comma 20 comma let's see 8. So okay, so I want to compare. So I'll just be printing to show us. Print. Did you give me everything? Okay, so let's just work with that. So print A equals to B. So what does this do? This compares. Okay, this is the equality. Test for equality. Test for equality. So I'll make my C 10 so that we can do A equals to C. Then test for non-equality, and this is for greater than and this is for less than, and this is greater than or equal. This is less than or equal. So the same symbol is used in other programming languages, like the modern ones. So yeah, I think I've not connected. So let's allow that to run. So the same symbol is used. It's just majorly that this may be different from for other programming languages. This and this. So if you are doing if for equality, you must use two equal sign. You want to check if something is equal to the other thing. You want to use two equal sign. So it says true. Of course, A is equal to C. So it says true. B is not equal to A is not equal to B. That's also true. A is greater than B. That's false. You can see, right? Then and A is less than B. That's true. Then A is greater than or equal to B. That's also false. And B is less than or equal to A is less than or equal to. Why am I reading the opposite? A is less than or equal to B is true. Okay. So when you want to use the less than or the greater or equal to, is when you want to do inclusivity, when the scenario requires at least. When you say at least 10 people, you now say greater than 10. You have cut out the 10 because they say at least 10. So you want to do greater than or equal to 10, right? So that is very important when you are using the greater than or equal. That is the in fact that is the application of greater than or equal to. Aside that, you don't normally use it. And you can see the answer is going to return true, false, blah blah. So it's basically so these operators can with these operators now we can now move on to conditional construct. So when you say if A equals C, do this. So the if is looking for true or false. That's what you want to see. It's not interested in 2 plus 3. So once you want to compare the result of 2 plus 3 is greater than 4 plus 5. You have to first evaluate 2 plus 3, 5. And then evaluate 5 plus 3, 8. Now you now check their equality. You now return true or false. So is that statement that the if statement will now act upon, not the arithmetic operation. Okay, so the logical or the conditional operators will always return a true or false value. Okay, always return a true or false value. And with this symbol, it tells you that when you want to implement not, you want to negate a true statement, you use that exclamation. Once I want to say if something is not this, then do this. So that means if it's true, change it to false. If it's false, change it to true. Okay? So I think with that we can move on to conditional the if constructs. So let's look at the three scenarios that we have. So we have a scenario in the if construct whereby we just want to test one side. Okay. So for instance, let me use the popular. Let's just do if constructs. So age is 18. Okay. So we are saying if age is greater than 18, okay, it should print that you are eligible to vote. Okay, else you should print you are not eligible to vote. Now this is more of a the basic if statement, whereby you are concerned about the value, or rather you want to give a response if it's true or if it's false. There are scenarios where you are not concerned with whether it's false or true. Okay, for instance, username is John, password is password 123. Okay, so we now say if, okay, if username is equal to John and password is equal to password 123, print login successful, else print invalid username. So you have that as, why is it doing it twice? Okay, so these are various scenarios where you can use your if and the else. You want to capture both end of the condition. Okay, you want to make sure that, okay, if it's like this, do this. If it's like this, do this. So you have your if and the else. If and the else. And then we do not necessarily need to put the unlike there are some programming that are very strict. You have to put your if construct, um, if condition in brackets. Okay, but in Python, you don't necessarily need to do that. Just type it and it knows what to do. But the important is that at the end of your if, you need to put in a a colon. Okay, that colon is very important. Okay, in fact, in this section that we are now, we're going to deal with colon, 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 and all of that in the section of this condition, and then in loops. What it does is it tells us that we're building a construct. Like I said, if is a construct, so it needs statement if true, statement if false. So what separates statement if true and statement if false is that colon. In Java or other programming language, sometimes you see them use the curly brace to quote what should be in the if true or if false. Then you have scenarios where I just want to show everything and then we run everything together. We have student scores in uh, in an exam. So we have maybe score is maybe 68. So want to grade them based on their scores. So that we have, okay. So we have someone that scores 90 and above, give them, no, that's too much. Someone that scores 70 and above, give them A. Someone that scores um, um, 70, then the next one will be 60. Okay. Someone that scores 70, 60, give them B, and anything below that should be C. Then, so you can have something like this, else. Okay. You can say else. Put in our column. Print. Then I didn't talk about the Python with marking, with tabbing rather. Okay, very very important. The tabbing is just 6 spaces that you need to leave between the what is it called? Four. Sorry. Let's confirm. Four. Thank you. So you have the option to specify when this score, if for instance if it's 70, what it should be. If it's 60, what should be 50, what should be. But we don't want to. Once you are anything below that, you just want to fail the person. So we want to say print uh, you failed. Spend less time on social media. And then, so what do you have? By the time we run this, we have um, a condition that handles multiple scenarios based on the score. Okay, and that is the if statement when you have um, different scenarios. So with this, we have been able to see how you can. This one is just for when you have multiple scenarios. This is when you have multiple conditions. Like if you want username and password, okay, you want username to be correct and password to also be correct. So you can see we use the and, okay, and this one is just for checking for the age. And so another thing is you can this can also be for all. Okay, like maybe you just want to make sure that okay, just if one is correct. For instance, if let me set my variable first. Has name is true. Has BVN false. Okay. So sometimes now we want to say we want to just say if. So this one we don't need to put in if this is true. We already know that this is a Boolean value. So we just put in has. Okay. We don't need to start saying has. We don't need to start saying has underscore BVN equals true. All those things we don't need it. Why? Because this is a Boolean type. It can only take true or false. So we can just say if has name or has BVN. Okay. If has name or has BVN, print you are eligible for a loan. Okay. So that means we don't need the person to have both. We just need one. So in that scenario, we are using or. But in case of authentication, we need both conditions to be correct. Or conditions rather. The username must be correct. The password must be correct. So these are some of the scenarios where you use your if construct. So if I run that and it says you are eligible to vote, which means because our age is equal to 18, so that works. Then the second one says login successful. Of course, the password and username is correct. The third one says you are eligible for a loan because has name is true and has BVN is false. So because one of this is true, it runs with that. So these are this and this is just showing us how to implement multiple conditions within your if construct. So if you have multiple conditions within your if construct, you might need this to show that. Then you have scenarios where you have in your conditions multiple outcomes or multiple values. You're expecting multiple values. You want to handle it this way. For instance, temperature, score, ratings. This is varies. Okay, it's not exact. So you want to capture with various scenarios in this form. This thing can also be used to classify data. Maybe you have a data, you want to clean it and maybe put it into bins. I don't want to use mapping, like list mapping. You just want to do it. You can use an if construct. So if the value is this, creating a new column and give it this particular value, and then you put that in a function, and once you supply the value, it returns whatever it is you have specified in this section. Then if I change this to false, change this to false, changes to this, changes to 17, we start having a different output. It says, has it run? It's still running.
It's the if the age is greater than or equal to 17 that you change, not age.
Jesus Christ. Sorry. Can you imagine? Okay, it says you are not eligible to vote. That's because the person is less than the requirement. Then it says invalid username or password because the password is wrong, though the username is correct. Then it says you are not eligible for a loan because the person does not have NIN and does not have BVN. Then the score, of course, you change that to say 45. You should tell us that the person failed. Okay. So I think any question? Okay. Then you also have the option whereby if a condition is true, you want to check further. You want to check further to see the behavior. For instance, what is that scenario again? So let's do nested conditions. So we'll see use our has BVN. I'll just assign it to true, and has name, assign it to true as well. Okay. This guy, why is it? You guys listening to me? It has created something for me, but let's see. Let me do what I want to do. So we have has BVN true, has name false. So if has BVN, so we want to now check. So if has BVN, we want to now check in if has name. So first, if BVN is true, so we want to check if the person has name. If the person has name, we'll tell the person account creation successful. Okay. So now we are still within the has name. So we want to add. What is happening? Why is that bracket there? Okay. So we want to check the scenario whereby the what is that now? What if it doesn't have a name? What should happen? What should happen if it doesn't have a name? So we want to tell the person print register for name. Okay, so we have been able to capture the inner block. The outer block now, what if has BVN is false? So that would be else print register for BVN. Okay, so let's run that and let's see what we have. So we have register for name, and that's because name is false. Okay, so you could have a situation whereby you need to nest your conditions, but don't let it to be too deep, otherwise you may be confused when you are reviewing the code later on. Alpha.
Yes, sir.
Okay, so that's we're taking care of the um, conditions and if construct. So we want to move on to loops. So we'll look at the popular construct, the for and while loop. Now loops are essentially designed for repeating aspect of your program. So if there are things you want to repeat, then you put them in loops. Now loops should be or rather care must be taken when constructing your loop so that it ends. Okay, something should end your loop. Okay, very important that when you are creating a loop, it has to end. Okay, if you don't do that and you run into an infinite loop, the program will continue to run endlessly, and that's loop for you. So people use that a lot, whereby you put a program to the computer and say, oh yeah, run this program. The program will be running, and will end up eating up the system resources. As it will get to a point, the guy will just say, I can't take it anymore, and the computer will just freeze. So let's see for loop in Python. So it's very useful, like when you want to go through items in a list or dictionary, or let me say items in data structures. For loop, in fact, hardly will you use the while, but you use for loop a lot. Okay, you use for loop a lot. So we have the basic for loop, which is probably to print range. Okay, so we have the for loop to print range. So let's have let's just do want to get numbers. So let's have for I in range, 1 to 5, print I. So this is just to give us the the idea of a loop just in basic form. Now, what we have done here, we have specified that we want to print, um, we have our for loops. This is just one example of a for loop construct. But there's something that you need to understand, that you have a for, you have a more like a counter here, you have the in keyword, then you have to specify the more like the where it's going to check from. Okay, unlike other programming languages, you may need to first declare your I at 0 and all this kind of thing. Okay, but in Python, don't do that. Just go ahead and write your variable. So we have for I in range 1 to 5. Here we specify where it should start from. Okay, it specifically says start from 1. Okay, for instance, if you just say for I will just put 5, okay, we'll have a different result. Okay, so in this case we say how do you add that thing again? Okay, I can't even remember it. Okay, I need to break this.
A new line.
Yeah, a new line.
And I think that's forward slash n. Okay.
So look at it. So you have the first one, we say 1, 5. So it started from 1 and stopped at 4. Okay.
Yes, sir.
The second one we say for I in range 5. It started from 0 and ended at 4. So the first one we asked it to give us some numbers 1 to 5. It gave us 1 to 4. Why is that so? It's simply because the range in the for loop, the way it works is that it counts from 0. So it's just to 0. This one will be your 0, like that. So this one will be your 0. This one will be your 1, 2, 3, and so this. So what's happening now is that it doesn't record the last part because of that 0 base um,
Yes.
0 base index that the for loop operates. So when you want to use the for loop, so you need to look at it and see whether this is the approach. If you want to use this, that means you have an understanding that the first value must start with from 0. But in cases where your first value has to start from, let's say 10, then you need to specify. Then you need to specify so that you get your result. Of course, I don't expect to get an answer with that. Okay? So you have the option to choose your start value, where it should start and where it should stop. Okay? Now I'm not supposed to change this. I'm supposed to copy and paste so that we can see the progression. Okay, so let's just take this down. Okay, so we can also print larger numbers. Okay, now but we want to say increase in this form. Okay, increase in 5. Okay, increase in 5. So if you have a somewhere by default it increases by 1, but you want it to increase by a particular number, then you may need to do something like this. So let's run this. Let's see what we have. Okay. Or we can even just do like this and just put in end and just add a comma. I think this will be much better. Oh, I thought I copied that. So I don't need this guy. This end of follow, blah blah blah. Ah, ooh, I will need it. So let's bring it back. Okay, so you can see it says 10, 15, 20, 25, 30, 35, 40, 45. The next number is 50, which is outside the list, so it just stop there. So that's for loop in one aspect. Okay, we can also have um, for loop being used in another area. For instance, I say um, okay, let's call it text. You try. But that's I want to take it something further than that. Python is a great program. Okay, so this is a text that we have. Okay, so another thing you can use your um, um, your for loop to do is to iterate through a string, whereby it helps to check each item um, in the um, in the string that was specified. So for instance, say for I in text, print I. So let's run that. That should give us, okay. So let's end it with maybe a dash. Okay. So with that, we are able to use the for loop to go through each of the item. But this is a string, but I don't want us to go into list. I would love us to see how can iterate through the items, each items in a list. But since we have not done this, let's just leave that for now. When we get there, we'll build on it. Okay, so then we have the while loop. So while loop is usually designed based on a condition. Based on a condition. So for instance, you want to check if something is true or if something is false. So for instance, you want somebody to be typing numbers and say press enter when done, or press comma, or press full stop. So while the program is receiving number, it will keep going, it will keep going. Immediately you see something that is not a number, it stops. So you can use a while loop to build your condition in such a way that your program continue to run until a particular your program will run until a particular condition is met, then the program terminates. So when you have that scenario, a while loop is appropriate. Don't even to bother yourself going to use for loop and then be putting if statement. Just use your while loop, JJ, and move on. So the while loop will help you to achieve that. So for instance, the implementation we did earlier with 1 to 5 with a while loop. So we can say while I is less than 5, print I, okay, then I plus equal 1. Okay, that's a compound operator, right? So but let's, because this is a condition, y does not exist at this point, so we want to set what our y is. So this will give us the same result that we had. Okay, I think we should start from 1. Now we can have the same result. Okay, so you can see we have 1, 2, 3, and 4. Okay, so as long as this condition is satisfied, is true rather, this will continue to run. But immediately it's false, it stops. And what this does is to increase y. If this is missing, our program will continue to run. Okay, because of, okay, so continue to run. You can see to continue to run. Thank God we have a stop and play and stop, so it's very easy. In some cases where that is not the case, the backend application can be very funny. So for example, we have a guess game with 3 attempts. Okay, so using a while loop, we want to do a guess game with 3 attempts. So the key is, let's say, 8, and attempt is 3. Okay, then the guess, which is what the person will enter, is 0. Okay, so we want to use a while, so we can say while the guess, okay, while the guess is not equal to, hey, I'm going to press something, while the guess is not equal to the key, right, and the attempt I've already written attempt as 3. So maybe I should use a count. Hmm? Let's call this count. I not look like attempt is no less. Attempt is less than attempt. So this is our attempt. Okay, so we're saying that why this guess is not um, when the person has not guessed right, and this count is less than this attempt. So we want to run. What should he do? He should add user to input. Okay, and then increase the count. Okay, so to run that for us, and now I didn't declare my count. It should guess attempt should be 1. Sorry, count should be 1 at this time because as the first attempt, so it should be 1. So the count should be 1. So let's see what we have. Guess the numbers. 5. So I should guess the number 7. Guess the number. Okay, so that means it's 0. It's 0 then. They did 2 attempts. Oh yeah, because I said less than. So let's use less than or equal to. I think will make more logical sense. What did I do? What did I do?
I don't think the guess should be the same thing as count.
I've corrected it. Let's see. Okay, so it's asking me for the 3rd attempt now. And then it stops. So, but we need to now print, but this is just a concept anyway. Guess guess random number, blah blah blah, and then if the person is correct, it returns the result. So let's say we want to add some condition. So for instance, when this while loop has ended, for instance, when it ends, are you with me?
Yes, sir.
So when when this while loop ends, it's either you guess right and it ended, or you guess wrong and you finish your attempt. One of them. But at the end, the loop will end. So at that end, we want to check if the guess is equal to the key. Okay, so to print you guess right, let's bring in our formatted input. You guess right after to tell us the attempt. After so putting our attempts. No, not our attempt, to count. After count attempts, you tell us the number of attempts. Else, just you lost after number of attempts as well. Make sure you have your space in the after and the attempt so it doesn't join them together. So I'll just take this to a new cell so it runs on its own. So let's have 3, 5, 6. Okay. Ooh.
Shouldn't the if
See,
else
see,
inside the law?
you lost after 4 attempts. It can't be inside the wire. It can't be inside. If it's inside, after you enter one, it will tell you guess wrong after one attempt. You enter the second, then you guess wrong after 2 attempts. That's what it will tell you. It will already be telling you that information. So if that's what you want, then you can move it into the. But one thing that after you are done, it will tell you that you guess blah 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 after so and so attempt. So that's the logic we want. But it's telling me I have 4 attempts, and I know why, because of my count. So let me just change it back to 0 so I can minimize my code logic. You can see. So I entered 8 in the first attempt. Say you guessed right after one. You guessed right after one attempt. So you can see. And if you run it again and maybe do all the attempts, tell you also you guessed you guessed you guessed it right after 3 attempts. So you can use while loop for something like this as well. And you can also add something here that tells them what the correct guess is. So if you after it says you lost after 3 attempts, the correct guess is, I'll be key. Just putting key there. Okay. It says you lost after 3 attempts. The correct guess is 8. So you can use your while loop. For loop will not do well in this game. It won't do well. Okay. Okay. Wait. This time is running. Okay, we started 30 minutes. Okay. So I've done one now. So let's finish up so that we can have a 5-minute break. Then we'll continue with data structures. see what we can do. Doing that. Okay. While loop, what is? Okay. So also let's look at loop control statements. So what are loop control statements? There are statements that are used to control your loops. Okay. For instance, if you're asked to generate some numbers and you want to avoid some certain numbers within the loop, how do you do it? So let's look at some of these loop controls. So let's look at some of these loop controls. So we have, let's start with break. So let's see. So for instance, if we say for I, let me use something else. For X in range 100, print X. Okay. If X modulus 5 is equals 7, break. Okay, sorry, I'm using one single equal to. So what are we saying? We're saying that, wait, can this thing, let it not go? Anyway, first, what scenario to run from start to finish? Let's have it on a line, and with let's see this guy still work. Okay, still works here. Let me use a shorter range. Okay, let's just use 10. I think 10 will be in a single page. Okay, so we have for X in range 10, print X. So now I want to check that if the remainder of the division is 0, just break. Okay, I've corrected that to break. So it means that this thing will not finish running, to stop somewhere. Okay, so of course, no, that's not where I wanted to stop. So why is it stopping there? Okay, no, that would be
Yeah. One modulo.
this thing. I don't want to confuse. Let me just speak. I want to, because now it's starting from 0, so it's mixing it up for me. So we have 2 modulus 5. That's 2 now.
But one modulo 5, the remainder will be 1.
Okay,
So
so it's not even continuing.
Yes.
Thank you. I think this should be, yeah, this is in the right place. So basically, what we're trying to achieve here is that we want you to break at a certain condition. Okay, so break is that just terminate the for loop, so it doesn't continue any longer. Okay. Then you have the word continue. Continue is just to skip. It's simply saying skip. Skip. That's what the continue construct does. Skip. So it doesn't. So in our own case, we want to bring the continue before it prints, so that we can actually see the skip at work. So if x is so between 1 and 10, we don't want to see odd numbers. Okay, so I change that reminder to 2, and then bring in my continue. So at the end, I shouldn't see odd numbers being painted. So let's have this here. I could share. I don't want you. Okay, so let's see. If you're watching this and you have a dark screen, just bear with us. The power is fluctuating. Thank you. Okay, so you can see we have it continue. So it starts from 2, because instead of printing 1, we say continue. So it starts from 2, goes to 4. There's no 3 because of the fact that we have asked it to continue. This my comma is in the wrong place. Okay, that's better. So we have 2, 4, 6, 8. By using the word continue, it's able to skip and go to the next iteration. Okay, so instead of, unlike break is to terminate, like don't continue, just end it here. Okay, for instance, if we want to use the for loop to implement that our guess game, we will need something like this: break. Once the guess is right, just break. There's no need, you have already guessed right, no need to ask you on that guess. Just break from the program. Okay, but if the guess is wrong, continue. Okay, or probably if guess is not true, continue. Or if guess is true, break. Also, but you can implement any of these in the program. Okay, then we'll have another one called pass. Pass is, it's not really doing anything. It's not really doing anything. It's basically something you add, maybe because you have planned to put in something later, or you have not um, decided on what you are going to do. And then you just say pass. This time let's print even numbers. Okay, so you can see, so we're able to print all the numbers. So when you use pass, you're just saying is between break and continue. So continue skip, like I said, pass just simply means do nothing. But later on, you may want to maybe make it to do something. You can add that as well. So, for instance, let's say um, uh, what should I add? I'm not going to terminate, starting an infinite loop. For okay, just leave that. Well, basically, it does nothing, and if you want it to do anything, just add that thing in front of it. The construct. So, for instance, if I bring this my pass down, because this is how it should be. Look up. Okay, so this is how it should be. So if I want to do anything now, I can add it here. However, it is want to, so it's basically not doing anything, and then you can now add what you want to do. So maybe you don't want to break, you don't want to continue, but you want to do something particular, like let's do something to make it make sense. X is even at this point. Okay, so to print F, it's like I will turn off this guy. You are over helping. It's confusing me. So it tells us X. Okay, not that like this. X is even at this at this point. So it doesn't continue like to skip. I mean, jump that listen. Break is terminate, but pass, it doesn't skip, it doesn't break. It will still run normally. But you can now introduce something that you want specifically to happen when that condition is satisfied. So when a division is zero, that means the number is even now, isn't it? So that's why I'm saying that okay, when you listen, pass, now say x is even at this point. And of course, it should print our x for us. Okay, so you can see when it gets to 4, it printed 4 is even at this point, 6 is even at this point, 8 is even at this point. Then you also have 2 is even at this point. But when you got to 1, you just printed 1 and move on. Okay, so that's that. Then lastly, you have the loop with else. So we can say, for instance, for I in range 10, okay, so this is just adding that you can also include the else construct within your It's like this is inside my for, abi.
Yes, sir.
So I've nested for loop. So let's take it out. So if you combine all this that we have learned now, we can use for loop to build the guess game. So we can use break when the guess is right, and at the end we can do this our else. That where we are printing, you guess right after you failed, blah blah blah. We should, I don't think we have that, but let's just do it. Let's just do it. So let's just use the logic. So I just copy the initialization I did. So let's do the guess game with the if construct. So we have our guess is 8 attempts, 3 guess count, and blah blah. So for I, so we use I in our count. Let's just write it. When we have anything, we come and debug. For I in range 3 at 0, 1, 0, 1, 2, yeah. So that's 3 guesses. Guess is equals int input three input guess blah blah. Okay. I want our else to be at the end. Yeah. So this is writing similar thing, but not with while, but with for loop. Let's see if the logic is correct. Okay, it's asking me for the third number, and it says you lost after 3 attempts. Correct guess is 8. Okay, that's correct. This one when we have provide the right guess 7, 8, terminates and says you guess it right after 2 attempts. So I think this works. So similar thing, but with for loop. You can see we made use of the break, and then we made use of the else with the for. So any question on if and for and while loop? I think I use this for loop then to do number uh, this binary. I think it's very powerful. It allows you to write shorter codes basically. I think it's decimal to binary. Like if you put in a number in decimal, it's going to return the answer in binary. And I wrote the code. I was like, it's 4 lines. I was like, no, this cannot be. How can it be 4 lines? Because I know when you write such code in Java or in C, you have a lot of, at least maybe 6 or 7 lines of code. But 4 lines, you're done. You're done because of how Java is designed. Sorry, because of how Python is designed to have shorter codes, basically. If you have shorter codes with the same result, it leads to efficiency. So take a 5 minute break and then we'll continue. So let's look at data structures in Python. Start with lists. So list is one of the data structures that we have in Python. From the name list, allows you to create a list of items that do not necessarily have to be unique and can be of different types. Okay, so let's see how to achieve that. So every time you see this sign, it means that is a list, and that's one thing that differentiates the list, tuple, sets, and dictionary. They all have their unique representation and symbol. When it comes to list, you need this symbol and the comma. Okay, some other ones may need curly brace, semicolon, all of that, something colon. But this is all you need to represent your list. So to create an empty list, you just need to say fav is equal to what? List. So by doing this, we have just created an empty list. So if we print it out, of course, it should be nothing. But if we want, we can also create a list with some items in it. 1, 2, 3, 4, 5. Okay, so and that will give us items in our list. So that, so you can see we have lists. So this is just a simple list. So we can also have a list that takes in other values, like let's say joy takes in 8.9, takes in 6 plus 1j. So your list can have different types within it. Okay, so you can see these are this is your list, blah blah blah. different types in it. And then indexing in a list is usually from zero. Usually from zero. So if you need the first item in a list, you just say give me 0. So let's just put that here. List continues. So we have print, and we're putting 0. What are we saying? We are saying I need the first item. Okay, first item in that list. First item in that list. First item is 1. So your list starts from 0. So let's look at another list. We have a list of fruits. Apple, mango, pear. After that one, we have banana, tomato, and grape. So here we can even do our for I in for fruit. Let's do it like for fruit in fruits. Okay, print it out. So to print each item in the in the list. So you notice that what is common here is your bracket, your comma. Okay, and if you are using text string, put it in quotes. Okay, so that's one thing you see there. Then if you need the first item, if I want to print banana, what do? I just say print what? Print fruits. Print fruits, and I put in the index. And counting from 0, banana is 0, 1, 2, 3. Okay, let's run that. So it gives me banana. So that is that on indexing. Now let's move on to another concept of list, which is very interesting. So how many items do you have in our list? 1, 2, 3, 4, 5, 6. Okay, so we want to look at list slicing. Okay, list slicing is very, very tricky, but basically it's all about getting a chunk of your list. So we'll just note that you have the start, the end, and then the step separated by column. So for instance, if I need the first item in a list, I just put in 1, right? Sorry, the second item give me 1. So this slicing is that now I don't just need 1, I need a range. Okay, so where should it start from? Start from 1. Where should it end? Start from end at 5. And the step, I don't need the step here, but let's just start with this first. So I have 1. Okay, so you can see 0, 1, 2, 3, 4. Okay, of course this n usually minus 1. Okay, so the n is usually minus 1 as well, and that's why we have this. So if I want to capture everything, I will just put in 0 and a dash. Oh, I don't want to clean this one so that we can be seeing each of them. So starts from 0 and my end is blank. Okay, slice, is from first to end. This is just first 5 from the second item. First 4 from the second item, and this from first to end. Okay, then we can have, what else can we have? Last 2. How do you print last 2? Last 2 items. Okay, last 2 items. You should start from negative 2. So if you want to look at it, negative 0 is the last item. So negative 1 will be the last item. Negative 2 will be the last 2 items. And where should it end? So it just be going, and of course there's nothing in the end. So of course that will give us a blank result. So let's run that and see we will have the last 2. Tomato and grapes happen to be the last 2. How do we get the first 2?
The first two starts from 0 to 3, or
No, using this method.
okay, using this method, we'll put the colon, we'll put 3, colon, and 3.
So when it says, when we put column and we didn't put any, that means it's starting from the beginning. And where is it going to end?
End at the beginning.
Where is it going to end?
End with the last item.
Which is what?
Grape. Grapes.
So I should run this. No, that's not what I'm saying. I'm saying that we want the first 2.
Okay, end at 2.
So this should be here.
Yes.
Okay. So you can see that you have the first 2 and the last 2.
Yes, sir.
And the position is like reverse. So unlike the other one, you put it at the beginning, put it first. The other one you put it in. So, but basically just to understand the concept. Somebody can say no, it's not like that. It's like this. But you still get the pattern is what? Get the 2. Get the last 2. Get the first 2. Whatever you want to use money, whatever you like. Do it any other way. You just want to get the first 2. Then if you want to get them in terms of like the step now, like you want to be skipping. If you want to get if we use 1, it will return all the fruits. If we use I didn't comment this, so this first 2 fruits. Now let's get the since it's reading my mind.
It means the AI use
Yeah,
the comments you
I didn't put comments.
Hey.
I didn't put comments, but I think it just assumed this is what I want to do, and which is right. So this will give us every other two. So you can see we have apple, it skipped mango, give us pear, skipped banana, give us tomato.
Okay.
If we want it the other way, we can say, okay, start from 1. So that means it will skip apple. Okay, to skip apple. It depends on how we want to slice our list. And if we assign this to a variable, you have, so let's assign this a comma b comma c is equals, instead of printing, just do this. I hope this works. Let's see what is in a comma b comma c. Print a comma b comma c. Okay, so you can see a comma b comma c, mango, banana. So we can actually slice and dump it into a variable. Okay, but you must know what you are doing. What I'm there, I know that it's going to give me 3. It's going to return 3. So I provide the correct number of variables. Okay, so you must know. And when I printed it, it gave me what is inside each of them: mango, banana, grapes. Is that correct?
Okay, so the first column, first column says to the end. So the other column says that skip
Every two,
every two.
starting from the second. That's why you have the start is 1.
Yes,
Starting from the second, skip
two.
2. So picks mango, skips, gives me banana, skips. So does that until the end. Then lastly is to get the list in reverse order. So we know that if it's just this trick that we use. What is the one you? Okay, I didn't store it. I removed it. The one you, where is this one? I didn't put comments here. Every 2 items. So if we say print fruits, and we do like this, blank, what is going to give us? Giving us all the items, right?
Yes, sir.
That means start and end is blank. So let's put 2 columns and let's see what we have. So you see, give us the same thing. Okay. So if we now put in a negative in the step, what do you think will happen?
So things to start on the back.
To go and start from the back. And because we say 1, to print everything. If I said 2, it will be doing that skipping. Basically, that we did. It will be skipping each of the items. So that's that about slicing. It's basic and has a lot of things within it. So let's look at some other list methods like to append. So we have fruits dot what append. Okay, so append is to add something under. Let me not call it under. To add something to the list. So fruit dot append. What other fruit have I? Guava. Let's add guava, and then I can run that. And let's print the list again. I think I can just write fruits. Okay, so you can see. Whoosh. I need I've added it because when I keep running it keep adding the guava. So I have a lot. So how do I fix this?
So make sure it's there at the guava ones.
Yes, using slicing. How do I fix it with slicing? So I'll just count what 0, 1, 2, 3, 4, 5, 6. I'll just put in 7 here to cut out everything. So if I say fruits equals fruits, and I bring in my let's see what that gives us. So I have my list back. I'll remove all the guava I was adding. Okay, so what you can see that you can use the dot append to add a new item in the list. Then you also have dot insert. Okay, you have dot insert. You can use dot insert to bring in to add to the list at a particular position. Okay, at a particular position. Insert. Okay, so at position 1, add pineapple. So that means add pineapple at the beginning of my list. Okay, so let's run that. Sorry, position 1 is the second item, not after the second item it adds pineapple to my list. Okay.
Yes, sir.
And this they will have extend. Extend allows you to add more than one item. So if you want to add more than one item at a go, then you may want to use extend. So say fruits, but that will add it at the end. Fruit dot extend. And then the items we want to add. Let's add say fruit tonic. Watermelon. And then let's have another one. I think there's strawberry. Okay, so you can see we have apple, pineapple. So at the end you have watermelon and strawberry. So when you want to add just one, use append. If you need to add more than one, you can just use extend. And then you have the insert, which allows you to put in the particular point. Then you have remove option, which is by using the pop um, pop method. So I say fruits dot pop. Fruit dot pop. And then I can add my fruits. So you should see that my pop has been removed. What's happening? Why are you taking long to pop? Pop, oh. Okay. So strawberry is gone. Okay, because we say pop. So it's pop always. That's when you talk about the what is it called? The FIFO and the LIFO concept. So pop will remove the last item from the bottom. And then insert will bring in an item. Oh, I think it was network. That's why it was not running. The network was unstable. Then we have other methods like sorting our list. So we can see fruits dot sort. Because it's a method, you must always put in your brackets, even if you're not providing any value. So now we have a sorted list, and then we can reverse it with fruit dot reverse. Okay. Fruits. We spend more time with fruit list and dictionary, but the other ones we just flip through them.
Sets and supers.
Yeah. So this is your list, and then you also have something that is, for instance, if you have an array. They even talk about array in Python. Array is also a data structure. Okay, but maybe that will be for another time. So we have fruits, which has been reversed. So reverse just to change the order. Then sort is to arrange the list. But one thing we must understand the
Sorry, reverse is to change it from the end, like
Yeah.
tomato. Why sort is to do it in alphabetical order.
Sort is going to actually arrange it in alphabetical order.
Okay.
Reverse, it doesn't sort. It just takes whatever is at the back, send to the front.
Okay, sir.
You just doing a slicing -1 and assigning it back to the fruit list. So I think we can move on. Any question? I think we need to stop here. This is 4:45. We're going to stop here. We stop in list.
So append can only do one at a time. Why
Append
extend?
append can do one at a time. Extend can do more than one. However, they both add to the end of the list. If you want to bring in at any point in the maybe insert, for instance, the instruction says insert at this particular point, so you need to use the insert method instead. Okay, um, and not append or extend. You need to use insert and then you put in your index and note that it starts from the first item starts from 0. So when you say insert at particular item, you look at where the item is and note the index. And the insert is usually after the position you select. So if I say point 1, that means that new item will take position second position.
Second position.
If I say point index 0, that new item will be the number 1. So that's what that does. So we'll finish with the list, and then we can move on in our next class to something else. So let's look at list comprehension. It's just a concept of creating lists based on certain conditions. So for instance, if I have to generate a list of numbers, okay, maybe list of numbers from 1 to 10. Ordinarily you just do for I in blah blah blah, okay. Let me turn off this AI assist so that we can. That's why I've not been adding my comments. So let's get generate list of numbers from 1 to 10 and store as a list. Okay.
Yes.
So ordinarily we use our for loop for I in range 1 to 10. So that means that would be 11. Okay. Then we now say we have not even created our list, so we need to create our list first. Our list will be numbers. Okay. So numbers dot append. Okay, numbers dot append, and then we put in our items. So if we run this, we should have 1 to 10, right?
Yes, sir.
Now, list comprehension, with list comprehension, you can do this with one line of code. Okay, and that is just the idea of list comprehension, to make life easy. So we'll have numbers again, and then in our curly brace we now put in our numbers. In this case, our number is just I, isn't it?
Yes, sir.
That's what we're appending. Then the range is for I in range 1 to 11. So if you look at this numbers dot append I, look up numbers dot append I
Yes, sir.
is what we just put in here as I, and then we say for I in range 1 to 11. So this for I in range is still there. That's what will generate our list for us. Let's run it, let's see. So we have the same results with fewer code lines. So that is just what list comprehension is. And if you want to generate even numbers, all you need to do is to say I times 2 is what? I times 2 is 2 now, isn't it?
That is the number is 1, yeah. Okay, starting from 1, yes.
So let's see. Okay, so you can see 1, you have 2, 4, like that. So you can actually do arithmetic in that part. You want to maybe raise everything to power of 2. To do that, you can see 1 raised to power 2, 2 raised to power 2, 4, 3 raised to power 2, 9, 4 raised to power 2, 16. Okay, so you have that option as well. So we'll stop here, and your simple lab will be to create a times table as a list. So let's use using 2 times 1 to 10 times 1 times 1 to 2. Let's just stop at 2 times 15, and 10 times 1 and 10 times 15. Okay, so you can do that. Create a timetable for this, so you can try to create everything as a single list, or maybe create different lists for each of them. The goal is to put in together your for loop, your looping skill, and list knowledge.
Okay, so I should do this
Yeah,
now or
you can make it tomorrow. Just note it down.